It's 11:43 and this is due in like 10 minutes. Anyways, this is on the optics lab experiment that we had on like hair strands and diffraction gradients and all that stuff. Stay tuned for in this video for me celebrating 10 subscribers, and I'm gonna do a special party trick. Anyways, so basically the things that we knew were the wavelength, length, slit spacing. Well, we didn't really know this, I would say. And we didn't know the angle, and we knew why. We didn't know this either actually. So we just knew length and y. And throughout the experiment, throughout the calculations I've done, I've figured out what this, and this are for the different things that we did. So, introduction. As we've learned from just having physics so far, we decided to take note of some of the given variables of Table 1. In a diffraction gradient experiment, a light wave that passes by an obstacle, so a hair follicle in one of our cases, will be split into two identical waves. At some point, they'll interfere both constructively and deconstructively, and you can find this from the equation over here. So initial observations show that moving it back and forth doesn't affect the y value, and we'll test the red and green light. And we're able to guess from that the greater wavelength of red light will cause it to have more separated bright spots. So a bigger bigger angle, bigger theta value, and a bigger y value. So the question I want to ask is, how can changing the slit spacing and controlling the wavelength affect the distance from the center and interference pattern? Which is basically our hypothesis, which is if the value of d increases or decreases, then the y value will be inversely proportional to that change. So based on this right here, which is a picture of like the light spectrum that I found online, you can tell that like red light would be around this over here, and then green light would be somewhere over here. So around these numbers. So these are the different materials that I've used for the experiments. There are two diffraction gradients, and then that's the laser pointer. So this is the entire procedure. I'm not really going to say it out loud, but it has links to all of these different tables and figures and everything that we've found just from doing the experiment. So the calculations. So from conducting an experiment on the 1000 lines per millimeter, we found all of these variables. So we measured this with just our pencils, and then we calculated this using these calculations. So using the equation from above and just the sine law, I think. Back to table 2. Let me just find where we were. Alright, so same thing with here. And this is basically the same stuff. We measured this using our pencils and blah blah blah. Yeah, that's basically it. So we also use a hair strand to basically like form like a double slit of some sort, and we found like a bunch, like we found that like the interference pattern included like a bunch of bright fringes, and this is what we recorded for the y value, and we calculated this and this, and we calculated these from the previous y value. So we took this one for red and then this one for red, added them together and divided by 2, and we got this one. And we did the same thing for this, and then we calculated this using everything over here. Anyways, in conclusion, hypothesis over here, we found out that like we found red light to be 693 and green light to be 547, and our other examples to be in this range and this and this and this. We found out that these three numbers match almost exactly with this range over here, and these three numbers match with this range. So it turns out that my calculations are right. And it turns out that D is also inversely proportional to Y, as the values decrease while the other increase. And these are some of the errors that could have occurred, which basically include like not positioning the laser pointer properly, marking the measurements wrong, and just having the diffraction gradient scratches there in the first place. So moving on to the better part of the video, it involves a water bottle as such. And basically what you do is you take the water bottle and you push it a lot like this until you basically can't do it anymore. So it looks like this, and then you pop the chop off really fast. And that's basically it. Thank you for watching my video. I hope you guys enjoyed, and that was my 10 subscriber